first line of the source code is considered as a reference for compilation, which is that salient feature that helps us to expand the source code and place every definition. The opcode macro indicates that the label associated with this macro is read buffer. Hello everyone, it is Dr. Ravi Kumar YB. In today's session, we shall learn about the macro instructions, which is specified in the second unit of your system software. In this macro instructions, let me tell you what is the meaning of macro. What is the meaning of macro definition? Then how these macro definitions are used. Let me tell you the meaning of macros first. The meaning of macro definition or macro instruction states that it is a notational convenience for the programmer. It is the meaning of notational convenience used by the programmer. For example, if there is any macro functions which needs to be used in our program, instead of writing repetitively the same definition, we just write the instruction which is sufficient enough to place the entire definition in place of instruction. That is the purpose of it. Let me take you into the details of it. For every occurrence of the macro in the whole macro body or macro block of statements gets expanded in the main source code. As you all know that the first, let me write down the program segment. This is line number 1, 2, 3, 4, 5, so on till 1000th line. Now, the compilation begins from the first line of the source code. Which is the first line here? The statement which is written at the first line is called as the first line of the source code, and this first line of the source code is considered as a reference for compilation. Then we have the next subsequent statements which are executed, which are compiled properly. Suppose in case of top-down approach, we will write down the main function earlier, then the definitions are written. In case of bottom-up approach, we write down the main functions later and the definitions earlier. If that is the case, I have written at 990th line number, I have written the main function. When does the main function gets called? As soon as the execution begins, the control comes to this part. Not to this first line of the source code. The control comes to the first line of this main function, which is located at line number 990. This line number 990 is considered as a reference because the main function is defined at line number 990. Then if there is any function call, the function jumps to that location and calls and executes the set of statements and then returns back to the same function. That is the next. At later point of time, if it comes across any one more function definition, function call, it jumps to the function definition and executes the set of statements defined inside the function definition and returns back to the next statement. This is how the function call or function invocation and execution takes place. Here in this case, the function definition is also defined. the function call is also defined. Whenever there is a function call, the function definition is invoked and the return statement returns the control back to the location from where it was invoked. This is how the functionality of the programming language works. In case of modularity, suppose if I have a macro definitions, how can I do that? What is the purpose of using the macro instructions? What is the advantage of using the macro instructions? Let me clarify you that. Suppose if I have a macro definitions called macro 1, then I will define certain set of statements within this macro definition, and instead of defining the same macro definition everywhere in my main program, I will just use one statement which is sufficient enough to place the entire macro definition into the place where exactly I have the macro instruction. That is, if I have the first statement which is requiring the macro definition, then the statement itself is sufficient enough to place the entire thing into this location. Suppose at later point of time, if the main function also comes across the macro instruction in one line, again it places the entire macro definition into this location. Similarly, if at later point of time comes across one more macro instruction, places the entire instruction into the same location. That is, we are going to have the expanded version of a program, not the original version of a program. This is how the macro expansions are done by the compiler. In case of this, these macro instructions are processed by macro processors. Then, which is that salient feature that helps us to expand the source code and place every definition of macro in the place of instruction? Macro processor. So let us see the salient features of that. Macro represents a group of commonly used statements in the source programming language. These macro processor replaces each macro instruction with the corresponding group of source language statements. This is known as the expansion of the macros. The same thing what I explained now, by writing the program, that is the pictorial representation of that, the same thing is explained here. Suppose if the compiler comes across any of the macro instruction, then the source, the definition where it is defined is copied completely and pasted in the location of instruction, so that the code gets expanded. That is the thing we are going to convey here. Similarly, using macro instructions, programmer can leave the mechanical details to be handled by the macro processor. These macro processor designs are not directly related to the computer architecture on which it runs. It is not directly related to the architecture on which it runs, whether it may be a dual core or it may be a quad core or anything. It does not depend on the architecture of the system. It depends on the type of programming language we are using to define the macros in our program. The same, macro processors involves definition, invocation and expansion. As I said earlier, a definition is one which is having the entire thing. This is called as a definition, this is called as an invocation, and this is called as an instruction. So we have all these things here: definition, invocation and expansion. Expansion includes placing the entire macro in place of this location, placing the entire macro in place of this location, so that the original source code becomes expanded. The same expansion is done here. Next, let me take you into the example of a macro instruction. That is, in this case, the assembler, we have a label called copy, and opcode start is the one which starts the execution of the program. Then we have a label called read buffer. Read buffer is the one, and it is defined as macro. I'm using the word macro here. The opcode macro indicates that the label associated with this macro is read buffer. If that is the case, which is that operand associated with it? That is input device buffer address. These are the two important parameters I am passing to that macro definition read buffer. By passing this information to the read buffer definition, the statements which are written inside the definition of macro read buffer gets executed, and after the execution of read buffer macro, it returns back to the location where it goes. That is how the functionality applies, right? But in case of this macro definitions, the entire definition is placed in this location. That is where the label is used. Instead of invoking the entire function and coming back to the location from where the invocation was happened, there was a chances of locating the function definition and returning back to the invocation point makes the time more inefficient. That is, it is not efficient to perform the task of invocation and returning back to the invoked location. In such cases, we have the concept of macro invocation. These macro invocations allows the programmer to place the entire definition in place of instructions, so that there is no need to invoke and get the data back to the location, so that these kind of redundant time efficiency, that is in terms of efficiency, is overlooked. That means we have the read buffer macro instructions. These read buffer macro instructions, let me show you the read buffer macro instructions here. This read buffer is the label part, is the name of the macro or definition of the macro. Input device and buffer address are the parameters present in the operand part. Each parameter begins with the character ampersand. Always please remember that ampersand is the symbol that is used to represent the parameter. For example, if I have a main function here and if I want to write down the function that is marks secured, this is the function call. In the function call, I will perform certain operations that M1, M2, M3 are the parameters I am passing. At this point of time, this will invoke any function definition defined as marks secured, that is marks secured with M1, M2, M3. After executing all these statements written inside this, it returns back to the location to the next instruction. This is how normally goes on. But in case of this, what happens if the entire definition is placed in the location of this during the time of execution? During the time of execution, entire definition is placed. Similarly, I will use the same macro, that is marks secured, at one more location. Then M3, M2, M3, M4. Now again, the entire definition is placed in this location, so that we have 1, 2, 3, 4, 5 statements inside this macro mark secured definition. All these 5 statements are placed inside this location, that is 1, 2, 3, 4, 5. Similarly, next the same 5 statements are placed here, 1, 2, 3, 4, 5. This is how the expansion process goes on. Now you will see that these are the main function that performs the task of that. In case of normal function invocation, the control jumps to the function definition and returns back to the location from where it was invoked. But this won't happen. During the compilation, everything is placed in place. Everything is placed in this location, so that there is no need to jump to the location and come back. So that this kind of invocation and returning the data from the definition is overcome in case of macro definitions. That is the main functionality of macro instructions. See, what is the advantage of using this? Let me tell you that if I have these instructions, these operations to be carried out in operating systems, especially there is a task of loading the data from secondary memory to the primary memory and swapping the data back to the location to the hard disk is needed in some places, because you shall see that this is a main memory. This is an hard disk. You have the hard disk like this. Whenever you have a small program segment which requires 10 seconds of execution and there is a need to bring the new data from this hard disk into this location, we need to swap the data items from here to here and from here to here. That is, we need to swap the data instruction or the main function which needs 10 seconds of execution into the hard disk and the data program which is requiring 15 seconds or 20 seconds of execution into the same location. In such cases, swapping is needed. In such cases, it is very difficult to perform the invocation tasks, and the time required to perform the invocation and getting the values of the returned information into the invoked position makes the system redundant. In order to overcome all those disadvantages, we have an advantageous situation called macro instructions. These macro instructions will copy the entire definition into the place of instruction so that the code gets expanded and there is no need to perform the invocation and returning the data back to the location. This is how we are going to perform. So let me take you into the more details. This is macro invocation. We have the read buffer here, opcode. We have F1 and buffer. This is the operand. Now we have a set of statements here. The statements varying from here to 190 to 255. The entire thing is considered here. This is a C loop. That means looping statement. This is a looping statement. This needs to be executed from here. This ends at first here and this has to be executed one by one and goes back and repeatedly does the task of execution. So if that is the case, what is the meaning of this C loop? Please see to it here. It is available at line number 190. This is available at line number 15. What is the meaning of that? As you all know that a looping is a statement that does the task of repeated execution of statements. The same set of statements. We also call it as an iteration. Now, in such cases, I do not want to go back to the location where it is defined and come back with the results. What I will do here is, I will just copy the entire definition in place of usage so that there is no need to jump from the invocations location to the function definition and come back with results. That increases the program execution time. Also, it is inefficient. It is not an efficient way of execution of system, especially when you have the looping statements like this. So, in order to avoid such kind of execution, that is invocation and getting the results back to the invoked location, we avoid using the function definitions. We prefer to use the macro invocation, that is macro instructions are used. These macro instructions usage will help you to place the entire definition in the place of its invocation so that it gets expanded and the execution continues easily without any mistakes or without any invocation at all. This is how we are going to do that. Usually end, that is macro end, is the end of the macro definition we define here. In that case, we have this function definition here, that is read buffer. Read buffer is the macro invocation or macro call. It gives the name of the macro instruction being invoked, and F1 and buffer are the arguments to be used in expanding the macro. The statement that form the expansion of a macro are generated each time the macro is invoked. That means each time when the macro is invoked, we place the entire definition into the location of its call. So this is how the macro invocation is performed. That means we do not have to do the operations of these macro invocation and macro returned values into the invoked location. Instead of that, we just have to place the entire definition into the place of its instruction so that the code gets expanded. In place of expansion, we are just going to execute the set of statements easily. This is how the macro instructions are performed. Kindly let me know if you have any questions with respect to the topics I discussed in today's session, that is macro instructions. Thank you very much. Thank you one and all.